Hello, I'm Trevor Ortega, and I'm a student here at Silverton High School in Silverton, Oregon. I'm a long-distance runner, a musician, and a backpacker, but my strongest area has always been my academic. I've always loved science and math, and I found that the perfect union of those has been engineering. I've had the opportunity this year to be working as an intern at Gonzaga Motors, a local engineering company. I started as an intern for a couple months, and then they put me on the payroll, and I've been working there for about 9 months now. I'd like to show you some of the projects I've been working on while I've been there. So with Gonzaga Motors, I've been working with this really exciting metal that's called a shape memory alloy, SMA for short. And what's really unique about it is normally when a metal heats up, it'll expand a little bit, but these SMA wires, they actually contract a bunch instead. So when I press this button, that'll send a current through and heat it up so you'll be able to see it start to contract. And you can see how this starts to move forward. And then once you release the current, it'll cool back down and return to its original position. And this property has been the basis of all the projects I've been working on with Gonzaga. So this first project I was working on actually ended up getting sent to Toyota so that they could look at some of the data, because what we were doing was looking at how we could use these SMA wires to dampen vibrations, such as what you might find in a car. So what we were doing is we had a hanging mass, and we'd drop it, and then collect data on how this would bounce. So we had a baseline, and then we compared if we were sending current through these and causing these wires to actuate, they'd stiffen up, and we saved the data and could look at how it was affecting the vibrations, and we were trying to find a way to dampen those vibrations using that property. This is one of my favorite projects that I worked on. It's a device to control the flow of fluid in an IV by pinching the tube shut. Turning the knob on the right allows you to adjust how much the tube is being compressed. This design is advantageous over a traditional actuator because it's completely silent. We went through multiple designs and ended up on this one where a spring closes the tube, and then when the wire contracts it opens the tube. This is a safer design and prevents overstressing the wire. I really liked this project because it has real-world benefits and a practical application in the medical field. So this is another one of my projects. It's a robotic arm that we're working on. The way it works is it has one of those SMA wires going up and around here, so then when you send power to it, it'll tighten it and raise the arm up. What I was working on is we get data from this rotary potentiometer that can tell us what the angle of the arm is at, and then I wrote code to process it on this Arduino, and then that tells the switch how much power to send to the arm so we can control its position. That's how it works. So this is the second version of the arm we're building. We made some changes, including using a metal, aluminum, that's lighter weight for the arm, and we used a higher quality joint so it's got smoother motion. At this point, we've got a bridge grant from the state of Oregon to further develop this because it's such a great way to showcase the properties of the shape memory alloy wires that we're using. It might not look like much, but this is a really unique way of using them that hasn't necessarily been used before. Thank you for taking the time to let me show you some of the projects I've been working on, and I hope you'll consider me as an applicant for the Honors College.